Hey everyone, and welcome. Today, we're going to dive into something that's honestly one of the most elegant and powerful tools you can have in your developer toolkit, the composite design pattern.
But before we get into the nitty-gritty, let me ask you something. How would you design a system where the exact same command works for just one single soldier and also for an entire army? Just let that idea simmer for a bit.
So that whole army problem, I like to call it the Russian doll problem. You know exactly what I'm talking about. Those nesting dolls where from the outside you can't tell if you're holding just one solid doll or a whole container full of them.
And in our code, we bump into this constantly. We've got our single objects, and then we have groups of those objects. And what happens? Our code gets filled with all these checks. If this is a single item, do this one thing. But if it's a group, then you got to loop through it and do that thing to everything inside. It just gets so messy, and your code becomes super fragile.
Right, so here's the core challenge, the big goal. We want the part of our code that's giving the instructions, the client code, to be blissfully ignorant. It shouldn't have to know or care whether it's talking to one object or a massive collection of them. It just wants to shout one command and know that it'll work. Period.
To really nail this down, let's head back to our army analogy. Let's pretend we're actually building the software to manage this whole operation. Picture this. You're the top general. You're looking out over your entire military force, individual soldiers, squads, whole divisions, and you give one simple command: move. So what happens? You're not going to run around telling every single soldier what to do. No way. That's completely unmanageable.
Instead, you rely on the chain of command. And this is where it gets really cool. The whole system is recursive. The general tells their colonels to move. The colonels don't just start marching, they take that exact same move order and pass it down to their captains. The captains pass it to the lieutenants, and the lieutenants pass it down to the individual soldiers. It's like a waterfall of commands flowing down the tree until it hits the people who actually do the moving.
So what this really highlights are the two fundamental types of objects we're wrestling with. On one side, you've got the soldier. We'll call that the leaf. It's the end of the line. It can't pass the order on. It just does the thing. Then you have the general or the captain, the containers. Their whole job is to hold other units and pass the order down to them. But here's the kicker. Both the soldier and the general understand the exact same move command.
And this whole elegant setup, this way of treating a single part and the entire collection in exactly the same way, well, it's got a name. It's the composite design pattern.
So if we're going to get technical for a second, it's a structural pattern. It lets you compose objects into these tree-like structures to show these part-whole relationships. But the real secret sauce is that it lets the client treat individual objects and groups of objects in a totally uniform way.
And that is the absolute magic of it. Just like the quote says, the client code treats everything the same. The general's command center doesn't need a special button for tell army to move and another for tell soldier to move. Nope, it's just one command: move. Simple.
Okay, so how do we actually pull this off? What's the blueprint for creating these super flexible tree structures in our own code?
It's actually surprisingly simple. This whole powerful pattern really just boils down to three key roles that all work together in perfect harmony.
All right, let's break them down. First up, you've got the component. Think of this as the contract, the shared rulebook. It's an interface that declares the actions everyone has to follow, like our move command. Second, you have the leaf. This is your basic building block, our soldier. It implements that move command directly. And finally, you have the composite. This is the whole, the container, our general. It also implements the move command, but it does it by turning around and telling all of its children to move. Okay, this all sounds pretty clever, right? But so what? What's the actual advantage of setting all of this up? Why should we care?
So let's talk about the payoff, which is huge. And yeah, there's a little catch we need to look at too.
Oh, the payoff is absolutely massive. First, your client code gets so much simpler. All of those ugly if-else statements checking for object types, poof, gone. Second, it's incredibly easy to add new kinds of parts. Maybe you want to add a medic leaf or a tank division composite? No problem. You can just drop them in without breaking any of the code that issues the commands. It just makes your whole system so much more flexible.
But you gotta wonder, right? With all this power and flexibility, is it always the perfect tool for the job? Is there a downside?
Well, yeah, there's one main thing you gotta keep in mind. Because you're making this one-size-fits-all interface for both simple things and complex containers, sometimes it can get a little too general. For instance, your component interface might have methods for, say, adding or removing child units. A general needs that for sure, but a simple soldier, it doesn't have children to manage. So the soldier object ends up having these methods that don't do anything, which can feel a little off.
So at the end of the day, the composite pattern is this beautiful way to build complex tree structures and treat every single part, from the tiniest leaf to the entire tree, in the exact same way. And that leaves me with one final question for you. Now that you see how it works, what digital Russian dolls do you interact with every single day? Think about the folders and files on your computer, or the layers in a graphics program. Once you start looking for it, you'll see this pattern is absolutely everywhere.